Hello, everyone. Today we're going to be solving and graphing one variable linear inequalities. So before we get into what exactly that means, if you could please at the top of the page, if you could try solving that problem right there, pause your video now and give it a shot. All right, your final answer, you should have gotten 3. A equals 3 as your final answer. First step should have been to distribute the number out in front. Once you do that, then it's just a matter of combining all your variable terms on one side of the equal sign and your constant terms on the other. So I moved all my variable terms over to the left, and then I moved all my constant terms over to the right, which leaves you with 2a equals 6. And your last step obviously was going to be to divide by 2 on both sides. Now, when it comes to solving, basically what we're going to do today is kind of an extension of this. But the key with this is that this equation right here, because there's an equal sign, that means that this solution right here, that's the only solution that will make that equation true. If you try plugging in a equals 4, it doesn't work the same way. If I plug in 4, if I plug in 4 up here in for a, I want you guys to see what happens. If I try plugging in anything other than a equals 3, well, negative 3 minus 4 is going to be negative 7. 1 minus 4 is going to end up being negative 3 times 3 is going to be negative 9. And that is totally not true. So a lot of times you can tell what your final answer is. Do we always plug it in? No. But if you want to be able to check it, you can. Today, that's going to change though, because of this word right here, inequalities. And that's because pretty much today, we're not going to be dealing with equal signs. And that's kind of the theme for the unit, to be honest. So when we talk about the different signs, there's 4 other ones other than equal sign that can be involved in any given equation. Technically, when you add in one of these signs, it becomes an inequality. But let's go over the first one that we have. So this first one, I always kind of think the inequality sign is always eating the side that's larger. So I always kind of think of it like a little gator. Since it's facing this way, this particular one, this is our less than symbol. And if you look not the next one down, but the next one down, this guy right here, that one, when it has that little bar underneath, that it's basically a less than, but it also means or equal. It's a less than or equal to. The other two are kind of like the opposites. If you have the mouth kind of like the mouth opening that direction, that is always going to be your greater than. And then down here again, when it adds that bar, that just means that's going to be a greater than. Oh, greater than or equal to. So those mean, again, pretty different things. But what we're going to be doing today is we're going to be starting off today by just graphing different types of linear inequalities. And the reason why we actually talk about graphing is because there is no possible way to list out all of the things that we want to do. So like, for example, if you look down at example number 1, it says we're going to graph the following inequality. X is less than 6. So right here, and I know it's a less than because the mouth of it is opening to the right, but because it's a less than symbol, technically you could stop here and that would be your final answer. But with inequalities, we'll usually actually go a step further and we'll actually graph our equation. Now we need to add some things in order to make graphing this a little bit easier. Whenever we create our graphs, there's some different things that we have to kind of keep in mind. And the first of which is the circle. So when we look down at example 1, since x is less than 6, that means 6 is kind of like I always kind of think of like a fence. Now, because I can't be equal to 6, technically 6 isn't considered a solution. It's just the fence line. It's like everything up until that value is something that's going to be make this equation true or inequality true. But we have to have a way of representing that on a graph that it's kind of like I said, like a fence. And we do that using circles. So on a graph, if it's a less than or greater than sign, we give them what's called an open circle. These are what we call open. It basically just means not colored in. And when it's a less than or equal to or greater than or equal to, these we give what's called closed circles. And I'm doing an awful job coloring these in, but you guys get the gist. It's a colored in circle. And these guys, again, are what we call closed. And that's because, again, when you have to have that distinction between, well, is it less than, is it greater than, is it equal to those values? So one thing I can tell right off the bat is if I'm going to graph example number 1, since this isn't a less than or equal to symbol, that tells me that we're going to have an open circle at that value. And then comes the shading. Now, some students like to use the sign. If you know that up here, again, since this is a less than sign, when we graph this, we want to shade all of the numbers or shade the direction that includes all the numbers that are less than 6. So since I'm less than 6, that tells me I'm going to shade everything to the left of it. Now, as a general rule of thumb, before we get going, in terms of graphing, what I'm looking for, I just need to be able to make sure that tell which side you're coloring. So as long as you make it obvious to me that you're shading to the left or to the right, that's usually what I'm looking for. If I have to sit here and kind of guess which direction is being shaded, then that's not something that I'll be able to accept credit for in the long run. But now for direction to shade, technically this is totally fine, but it's only when the variable is on the left. These are more of kind of like shortcuts, if you will. So like, for example, if your variable is on the left side of the inequality sign, then if it's a less than symbol, we always shade to the left. If it's a greater than symbol, that's the other direction, that's going to be to the right. And then the same thing holds true for actually the other ones. If you have, oopsies. So if it's a less than or equal to or a greater than or equal to, then we still shade in those same directions. Anything less than is always to the left. And anything greater than is always to the right. And so number 1, this is what the graph of that equation or inequality, actually looks like. So I have kind of some notes up at the top here, but you'll see here that every graph should kind of have 2 things going on. There's always going to be shading to the left or right of some number, and there's an open or closed circle on that border number. So what I want you guys to do, actually, I want you guys to pause your video and I want you guys to try graphing example B and go. All right, this is what you should have had. Your border number should have been at 5 right here, or -5. And because it's a greater than or equal to symbol, the equal to lets me know that the type of circle that we have is going to be this closed circle. So I'm going to have a filled in circle at 5. And because I'm greater than -5, I'm shading the direction that includes all the numbers that are greater than or equal to -5. So when you fill in that circle, it's kind of a way of also saying you can be equal to -5. Because if I plug that in, -5 is totally greater than or equal to -5. If you take away the or equal to parts, then that actually wouldn't be true. That's why we would have put a closed circle there. But in this case, since it's a greater than or equal to symbol, that's why you would have had the closed circle. Now, they're not all going to be just straight up graphing ones. Sometimes you might have to go through and solve first in order to be able to graph. Now, the nice thing about this is when you're going to go ahead and solve, a lot of what you would do with normal equations, like we did to start the video, still holds true. You still want to look to get all variable terms on one side and all constant terms on the other. So for me, since I have my variable term on the right side already, I'm going to combine my like terms, -7 and +1. There's a lot of ways you could have gone about this, but that's going to end up bring my 4b down. -7 + 1 is going to end up being -6. And now I'm gonna get all my numbers over to the left-hand side. So I'm gonna add the 6 over to this side. Negative 18 plus 6 is gonna end up being negative 12. And that's gonna be greater than 4b. Now, this is usually where we have to be really careful and have it up here. But there is one kind of tricky step when it comes to solving inequalities. And that is anytime you multiply or divide any side by a negative number, the inequality sign is going to flip-flop or just flip if you think about it that way. And it's going to do so because when you divide by a negative, your sign technically flips. The signs on both sides, excuse me. So like, for example, I'll go through one in just a moment, but like if you look through and like this one, the number in front of b that I have to divide by, it's a positive 4. So to get b alone, we're going to divide by a positive 4, but because it's a positive, I'm not going to switch that sign. So b is going to, we're going to have negative 12 divided by 4 is going to be negative 3. And now here's the deal. A lot of times, especially like if you're a fan like me, I always like to typically have the variable on the left-hand side. So you are able to flip-flop these if you want also. Another reason why you would flip-flop them is if you switch the side that both things are on. So you are allowed to switch those. B is allowed and negative 3 are allowed to switch, but you also have to remember to flip the sign. So technically this right here is our solution. It's any number that's less than negative 3. So on my graph, that just tells me that I'm going to have an open circle at negative 3 because I don't have an equal to sign underneath. And because I'm less than, I'm going to shade everything that's less than negative 3, which is everything to the left. All right. Now, if you look at something like part B, I want you guys to try part B on your own. Just be really careful of what's happening up here. If you ever multiply or divide both sides by a negative, you just want to remember that you're going to have to flip-flop. So I want you guys to pause your video and I want you to try part or example B on this one right now. All right. So for this one, and I forgot to write the answer on here, but your final answer, you should have got x to be less than or equal to a positive 1. Now let's see how we get that though. Now I didn't finish this one because I wanted to stop and talk through, but if you got this, that means you solved this wonderfully. Now, if you get to this step though, I wanted to show you what a case would be when you have to flip that sign. And this is actually the perfect case. If you combine your like terms, if you distribute correctly, kind of get down to a place where all of your variable terms are on one side and all of your constant terms are on the other. Here, I want you to see what happens. If I have this negative 3 in front of the x, that means in order to get x alone, we have to divide by negative 3. And this is a classic case of when you have to flip your sign. Because on the left-hand side, negative 3 divided by negative 3, that's going to turn, instead of being a negative like it started, it's going to switch and it's going to become a positive. On the right side, it was a negative 3x, but when you divide by a negative 3, that's going to turn out to be just a 1x or an x, but it's positive. So since the signs on both sides switch, which only happen when you multiply or divide by a negative, that means this sign in the middle also has to flip. Now, if you solve this, if you did this a different way, you got all of your x terms on the left side and all of your constant terms on the right side, you would have gotten the same thing. I'm going to flip this around because, again, I like having my variable first. So I'm going to flip my x and my 1, and that means my sign has to flip as well. So either way, you should have got x to be less than or equal to positive 1. And because it's equal to, that tells me I'm going to have an open circle down here at 1. And you should have shaded to the left. Beautiful. Everything that's less than 1 should have been shaded. And away you go. All right. So if you guys are now done with the video, if you want to try some of the You Try Nows for extra practice, go ahead. But you can move on and start working on your homework.